welcome back to Advent of Code. Oh, damn it, I have to turn that. Alright, so Advent of Code 2017, day 19. So in the final few. A series of tubes. Classic meme. Alright, so what have we got here? Somehow a network packet got lost and ended up here. It's trying to follow a routing diagram. Let's have a look at this. Okay, it looks like we're going to do a breadth first search or something. But it's confused about where to go. Its starting point is just off the top of the diagram. Okay. Lines show the path it needs to take, starting by going down onto the only line connected to the top of the diagram. It needs to follow this path until it reaches the end and stop there. Sometimes the lines cross over each other. In these cases, it needs to continue along the same direction and only turn left or right when there's no other option. So this is a directed graph, not undirected. Interesting. No, it's not. It's not even a standard graph because it sort of is, but okay, let's just read on. So it needs to continue going in the same direction and only turn left or right when there's no other option. Okay, only when you get to a junction can you turn left or right. Someone has left letters on the line. These also don't change its direction, but it can use them to keep track of where it's been. For example, okay, there's some letters. Given this diagram, the packet needs to take the following path. Hello, DIJ. Now goes man versus machine. This year has been 2017 has been pretty alright, I think. Not too hard. The only one I got really stuck on was 16, which was like a permutations problem where you had to work out what a permutation will look like when you do it 1 billion times. Which is a lot. Alright, seems we've got some sort of map, some sort of... let me read the rest of this. Given this diagram, the packet needs to take the following path. So you start at the top, go down through A, continue on to the first plus. Okay. Travel right, up, and right. Okay, so you follow the line, go through C, go through D, go through E, and stop at F. But you don't have a choice in this matter. Oh, you okay, so you actually just You actually just have to follow the path until... So it's this. You don't actually have a choice. There's no junctions where you can take a left or a right. It's actually a fixed... Okay, it's hard to see here because it's not spaced evenly, but... Alright, I sort of understand. So it's like those kids' books where you just have to follow the line and see where you end up. That's what they're asking? Okay, I mean, conceptually it's not hard. It's a bit tricky to interpret this map though, because you'd have to, well... You have to parse all the characters. The end is Q. I think I saw it already. There, that's the end. Unless it's a red herring, there could be other ends. Yeah, it could be. What will the end look like? Will it be a letter? Are there any other ends? Let's have a look for all the letters. We've got A, B, no B, C, D, E, F, G, what is going on with G? I don't think that's an end. H, I, J, K. So I think Q is the end. Okay, fine. Yeah, this is kind of messy too. What's the best way to represent this? Oh, I see. So if you have this is a junction, you actually cross over, but then you go under the other way. That's okay, fine. That's okay, because the only time you'll actually stop is when you hit a plus or a letter. There should be space after you. Alright, I don't know. Let's start coding it. Okay. Or let's say line in f.readline.strip. No, line in f.readlines. All right, so we want to build a grid. Grid dot append line dot strip. So we have a grid. On the top row, there's only one entry point. So we have a location and a direction. So we start there. So that's the character we're looking for. Start I equals 0. Start j equals the first row dot index, just that character. That's where we start. Direction I, let's call it DRI equals, so we want increasing I. So let's say 1, 0. So increasing I, not increasing j. That's its direction. Okay. So while grid okay, so ij equals start I, so we start at this location. While grid ij is not equal to q, so I'm assuming that's the end, q. We keep stepping in the direction we're going. So confusing. Okay, so we're currently going down. So we keep going down until we hit either a plus or no. The rule is we go down until the space after us is empty. Yeah? So while grid I plus DRI j plus dirj, so that's the next space ahead of us, is not equal to space, we update I j So I plus equal dir j plus equal dir j. Right? We also need to keep track of what was visited. So if grid I j dot is alpha, then I put it in the list. So that accounts for one straight line movement until we hit an empty space ahead of us. That means we're going to turn now. Now we have to find the direction we're going to change to. This is tricky. Well, it's not tricky, it's just messy. Let's just handle each case by case. So if we're going vertically, we're going vertically, that means we now have to choose whether we're going to go left or right. We're going horizontally, for sure. We have to figure out whether we're going left or right. For drj in -1, 1, if grid I j plus drj is hyphen. Is this the right character? Probably. Break. So it'll be one or the other. So we'll break out of that when dirij is the correct direction. So diri is 0. We've changed to horizontal. Else it's the other way around. So for dri in -1, 1, grid I plus diri equals a vertical line, break, drj equals 0. Okay, so we've updated dri and drj. Now what? Is that all? And then keep thinking you're saying my name. Oh, dirj, yeah. This is the only problem I can think of where I've actually used that variable name. I don't normally name things like that. I would normally do dx. Yeah, that's weird. Why did I not do dx dj? That's what I normally do. Di dj, dx dy. That's calculus. I don't know why I chose DIR this time. It's a really weird map. Okay, so I think this accounts for every possible... movement around the grid. Alright, and now... Of course, we're out of range. If grid I plus dir I j string index out of range. So we're at 1-1. Wait, how can that be? That's not right. IJ is the starting value. The starting value is... print start I start J. What are we starting with? Starting at 0, 0. What? 1, 1 is empty, it seems. Well, for one thing, we're starting in that corner, but we shouldn't be. Why? Dot index. Let's start by printing the grid itself. Okay, so we've got a grid. Oh, of course. Strips white space characters. Oh, we don't want to strip. This is one rare occasion where we don't want to strip. But we do want to strip the new line characters, so how do we do that? Just say dot replace. It's taking all the white space from the front, but we need the white space. Just that will replace new lines with nothing. Okay, check that. Stuck in an infinite loop. Okay, we're getting somewhere at least. Well, let's have a look at the grid. Looks like that, and we've got IJ is 039. Okay, good. That's a start. All right. R strip. Okay. Yeah, I might switch to that. I didn't know about that one. Okay, so this is wrong. So, okay, so the first move we do is we move down. That's correct. So we move down to this line here. and then for some reason we go to the left. So what's... We don't have any break condition here. No, we do. It's if we hit an empty space. So until there's an empty space ahead of us, these operations should keep going. Ah, whoops. So this is outside the while loop. This shouldn't be inside the while loop. So this is move forward only. And then we do that until there's a space ahead of us, and now we change direction because we're at a junction. Once. And then we go back to the next iteration of the outer while loop. Let's try running that now. Okay, we're out of range now. So we've gone... What have we been doing? So we're going down, correct. Go down one by one until... until 9739. And then we change direction to go to the right. Is that correct? So it's this line here. Go down. To here. 90. Line 9 to 8. Okay, yeah, that's right. And then we go right. Okay. So far so good. Then go right a bit. Until we get to 9769, and then we go down again. Correct. So it's about the right place, yeah. And now we go down till we get there. Okay, so until we get to 116, correct. And now we go right again. Alright, so far so good. Alright, let's just assume this is sort of correct until we get to... Until we get to 197, 189. Where was I going? Yeah, here. We go here. We go down till we get to here. We go right till we get to here. We go down, right, up. I don't see anything wrong with this so far. Right, 197. 189. So that's here. Oh, really? Hang on, this is probably not their fault. It might be my IATE. Okay, so basically there's no white space at the end of these lines. Now, it might be that my IDE was removing it. I hate it when my IDE does stuff I didn't ask it to do. Just leave all the characters that were in the file. Or it might just be a Windows thing, I don't know, that it just does that. It just removes what it thinks are redundant whitespace characters. Basically, all these lines, I need to add spaces until... I think it's actually the browser that's doing this. No, it's not. There's clearly whitespace characters in the browser file. All right, let's try a different thing. I think VS has that as a feature. Yeah, it's probably the IDE. Wait, no. Oh yeah, it's because I pasted it into the IDE. Instead, let's just save it directly from the browser. Then the IDE shouldn't be altering the file at all. Okay, so we'll save it as input. So now, if I look at it, it might still remove it. Oh no, there is white space here now. Yeah. We don't want that last line though. It doesn't matter, but take that line out. Yeah, there's white space here. So as long as I don't edit in the, as long as I don't edit anything in the IDE and save, that should be in the original file now, yeah. There we go. No, we got an error. Just all the way over here. List index out of range. So this time it's at 199.51. Oh, it's going off the end of the 199. $51. That's here. This one. Oh. I shouldn't have removed that last line. I shouldn't have tampered. I defied my own advice. I shouldn't have tampered with the file at all. I said I wasn't going to, and then I removed that last line in the editor. Just don't touch it. All right, save again from the browser. Okay. There we go. We got an extra line here. Don't touch anything. Run it. There we go. Mega. Okay, now that must be correct because I can't see any other way we would get a bunch of letters without going wrong somewhere. Because we've arrived at Q. There's no way we would get to Q by some other route, so it must be correct, right? Let's check. Correct. The packet is curious how many steps it needs to go. For example, using the same routing diagram from the example above. Are you kidding me? Part 2 is just count the number of steps? I mean, however we've coded this, that must be super easy, right? However we've coded this, there's going to be a line somewhere where we're adding 1 or something. We just count how many times we do that. Unless I'm missing something. I don't think I am. So we're counting it. The first line counts as a step. Well, in our code, it doesn't. So, okay, we'll add 1 to the result. This is a suspiciously easy part. Okay, so we want to... I'm not sure where else they could go with this map, though, as a part 2. Like, it's kind of... there's no room for experimentation because there's a fixed route you follow. All right, so where did we? So this is here. This is the bit here. Every time we add one here, we add one here. And we'll add one. Could be one off or something, but I think it would be steps plus one. 16,408. I guess that makes sense. It's like 100 width, so yeah. Correct. That was a gift of a part 2. That's unusual. Right, I'd like to see ChatGPT handle that parsing of that map, but it probably will, but... Alright, so... Couldn't figure out a part 2. Yeah, it's like all the complexity in that question was just interpreting that map, really. Because it's a bit weird, the way they've got different symbols for junctions and stuff, but once you've interpreted the map, there's nowhere else to go. All right. So this is really a test of whether ChatGPT can interpret that right there, because the words are probably not enough. You need to have a visual understanding of that. Probably can though. So it's going with enums basically for up, down, left, and right. That's more readable than what I did, but I like using vectors anyway. Well, he's using vectors, but encoding them as enums. It looks plausible, but he could get tripped up if he's not understanding how the junctions work, but let's try it then. AYRPV meg Q, yeah. Okay. In that case, it'll be easy for him to do the steps. Let's... This is the one mistake he might make is whether he's including the first step correctly. So he could be one off. I think that's an easy mistake to make, because in theory you're walking off the end of the map, but the way you would code it, you wouldn't code it like that. So Oh. Hang on. He's not giving me the full code. He just wants me to modify one method. It's annoying when that happens. Well, he's... Hang on. Just ask him for the full program. I don't know what he wants me to... Please give me the full program. He just wanted me to change a couple of methods. I should probably update my prompt so that I always say that. Well, the number is correct, I guess, so that's fine for part 2. But what he's the letters seen along the path, he's got that wrong, but he's used the same method for that. What? Result letters equals... What was he expecting? Where was he expecting to get the letters from? He's not even outputting them. There's literally no mention of the letters. Doesn't matter, he got the number correct for the part that I asked him about. Alright. I guess that's just kind of legacy code that I forgot to remove. It has step, but he doesn't fetch any letters, but I think he's just left that printing statement in there, forgot to remove it. Because he only wants to count the steps now, but he seems to still be trying to print the letters. Okay, so that's the win. ChatGPT. All right, day 20. Good thing the AI can do simple counting, yeah. I mean, that's one of the main things we use computers for, because humans are terrible at counting. Suddenly, the GPU contacts you, asking for help. Someone has asked it to simulate too many particles, and it won't be able to finish them all in time to render the next frame at this rate. It transmits to you a buffer, listing each particle in order. For each particle, it provides the X, Y, and Z coordinates for the particle's position, velocity, and acceleration. Ooh, we're going to be using Newton's laws. Alright, each tick, all particles are updated simultaneously. A particle's properties are updated in the following order. You update the velocity, makes sense. Update the position, sure. Because of seemingly tenuous rationale involving Z buffering. What's Z buffering? Something related to computer graphics. Okay. The GPU would like to know which particle will stay closest to the origin in the long term. Measure this using the Manhattan distance, which in this situation is simply the sum of the absolute value. Yeah, okay. For example, suppose you only... Wait, so... We're just simulating where the particles are moving. That seems fine. That's easy. And we're keeping track of the closest one to the origin. How many particles are we dealing with? Because that seems a bit easy. Not too many. That's fine. Yes, I don't need to do anything clever like I don't even remember what algorithms are clever for this. Like well, for Manhattan distance it's a bit, I know stuff that's clever stuff you can use for Euclidean distance, like I don't know, KD trees and clustering algorithms and stuff. So if you had thousands and thousands, millions, then yeah, you could have efficient ways of keeping track of what's closest to you. But okay, here it's just a straight for loop, I guess. Wait, what do they mean by stay closest in the long term exactly? Oh, maybe I... Okay, so we've got two particles on the x-axis. So 0 and 1. The origin is here. It's got 0 and 1, 1, 0, 1, 0, 0. Actually, I don't understand what they're asking here. At this point, particle 1 will never be closer to 0 than particle... to the origin than particle 0. And so in the long run, particle 0 will stay close. Oh, they mean eventually. Eventually we reach a point where one particle will forever be the closest. Oh, that's not as obvious then. You need to figure out when all the yeah, that's not as obvious then. You just need to figure out at what point they're all moving away from 0. Would that be enough? Okay, so because some might be coming close to 0 but then going past it and stuff like that. It's in 3D space, so these have a 3D acceleration as well, so they're accelerating towards some vector. So wherever they're going, the acceleration is bringing them closer and closer to that vector. Okay, fine. So I guess we want to find the point at which all particles are moving strictly away from the origin, but that's not enough. Because you might be moving away from the origin, but your acceleration is towards the origin. In which case, at some point, you're going to turn around and come back. So we want the point at which the velocities are all pointing away from the origin, and the accelerations are pointing away from the origin. So there's no chance they would turn around and come back. Is that once we get to that point, is that guaranteed that one point will be closest? Not necessarily. Okay, maybe... I mean, at the end of the day, isn't this really just down to the acceleration? Whichever has the lowest acceleration, smallest absolute value of the acceleration, then no matter what direction they're going initially or whatever, eventually, as the particles have given themselves enough time to stabilize, surely whichever has the lowest acceleration is the one that's going to remain closest. Because all the other ones are getting further and further away at an increasing rate. So isn't it just aren't we just calculating who has the lowest acceleration? I don't see how... I mean, in this example, that holds true, right? So, acceleration for 0 is smaller absolute value than 1, and 0 indeed is the answer. In that case, we don't care about any, I don't know. I don't see any argument against what I've said. If you've got if you've got smaller acceleration, then all the other particles will just race away, won't they? And you'll just not race away as fast. Interesting problem. Okay. You can try that and see. I mean, so it's literally just find the A values and pick the one which is the smallest absolute value. Wait. And we're going by Manhattan distance. I think it wouldn't matter though whether we did a Euclidean or Manhattan. I think they would be equivalent essentially for the lowest. But we'll go by Manhattan. Yeah, because that's how much the Manhattan distance is changing. It's an interesting problem. Okay. Yeah, I mean, the more I think about it, the more I'm convinced that you just care about acceleration and nothing else. I mean, current distance, current velocity, what does it matter? In the end, you're just going to approach a certain vector and you'll just keep accelerating on a asymptote. You get closer and closer to that vector, never quite getting there, but all right. Fine. I guess we need to unpack this. There's no space between these commas. Okay. So we can do split by comma space. That gets us that as one token, that as one token. Okay. Let's call this, I don't know, AX. Let's say PX, VX, and AX. But we're not going to store PX and VX for now because we're not using it. So AX equals that. But these particles don't have ID numbers. What do they want us to? We go by the. Okay. Whatever position they are in this array. Okay. Okay, fine. Okay, so A equals tokens 2, so that's the third block. 0, 1, 2, 3. 3 characters in. So we want from 3 and the tail from the end -1. So that gets this region here. Don't move stuff around, whoops. That region there. And then we want dot split on the comma. And then we want tuple int k for k in that. So that should just give us a vector. So ax dot append a. Once we've done that, we want to say I equals the minimum of a of the indices given the key, which maps a vector to an index, because we're using indexes here, to the, okay, so we want to take the ixth item in AX, and we want to sum the absolute values of the k's for k in that tuple. All right, bit of a mouthful. Sum of absolute values. That's the Manhattan distance. And we want to minimize that. So just print I. Is that it? 158. Let's hope that's the answer, because seems reasonable. Not the right answer, too low. So was my argument completely wrong then? Let's have a look at what we're looking at here. (002). So we need a tiebreaker, don't we? So how many have that same value? It's basically a tiebreaker between these. All right, let's first make a helper method here. Because if 2 have the same acceleration absolute value, then it's a question of which started closer and so on. You have to, oh man. Okay, fine. Define, let's say, norm of a vector. Return that. So we want, so instead of this, we want norm. Okay, let's try this. Candidates equals that equals x for x in AX if norm of x equals norm of what we've just found. C. Oh, and print them. So there's just two candidates. Is it just the other one then? What's the index? Oh, we didn't print them. Okay. I for I in range. Length. If norm. And we're going to need a different letter here. One, 5, 8, and 2, 4, 3. So is it just 2, 4, 3 then? Correct. I mean, they could have made this harder, couldn't they? They've been a bit generous here. If there were lots of particles that had the same acceleration, it's still tricky then, because then you have to decide. You have to work out. You have to find the point at which they're all going away from 0, which they will eventually do. So they may be going towards 0 to begin with, but then accelerating away. And after that point, you need to look at their velocities and their I'm not even sure what the cleanest, complete, and 100% correct method is for doing that. Well, whatever. They've been generous and they've given us only 2. Alright. To simplify the problem further, the GPU would like to remove any particles that collide. Particles collide if their positions ever exactly match. Because particles are updated simultaneously, more than 2 particles can collide at the same time and place. Once particles collide, they are removed and cannot collide with anything else after that tick. In this example, particles 0, 1, and 2 are simultaneously destroyed at the time and place marked X. On the next tick, particle 3 passes through untold. How many particles are left after all collisions are resolved? How do we know when all the collisions are resolved? Should we just simulate like 1,000,000 steps or something and then call it a day? What is the actual criterion? It would be how do you know they'll never collide again? I don't think you can. So these... Oh, you can. You know... So the position is a quadratic equation. You know the position of the point at any time in the future according to the quadratic equation. And you could solve that quadratic equation for every pair of particles to work out if they collide or not. But do we even need to bother doing that? I think if we just run this enough steps, we'll eventually have all the collisions happen. Let's say if there have not been any collisions, like okay. This is interesting. I think we just simulate it then. So we say Alright, so this doesn't actually print the final answer. You just have to choose one of those two values. Alright, so alright, so we need px equals that, vx equals that, ax. Alright, so we want to basically do this. So we've got P, Px. I'm gonna take token 0. And then we've got V. So we've got all those values. Ever exactly match. Could we have particles that actually start matching? Maybe, I don't know. We can account for that. So let's say while true. Okay. So let's start by checking if any two match. It's not efficient, but we have to. We have to just say if set of px well, no, that's not what we want to do. So okay, maybe we just, yeah, I would like if you use a set, you can't work out. Okay, let's just do this. Let's say px.sort. So sort it. Right, so that'll sort them, and then we'll be able to see if two are the same, they'll be next to each other. So for I in range, so we want length of px minus 1. If px minus 1, sorry, pxi is the same as pxi plus 1, not only do we remove those two, but there might be others after. So while, okay, so j equals I plus 1. So we're trying to find the last of all the ones that are the same as I. So we know that j is sitting on something which is the same as I. Okay. While j is less than length px minus 1, and so that's, we're saying while it's to the left of the lastmost element, and the element to the right of it also is the same, and px j plus 1 is the same as px I, just increment j. So we keep pushing j forward until we get to the final particle that is the same as I. Oh, there may be many, but we know there's at least 2. Okay, so we're now sitting on the last one. So we now want maybe there's a cleaner way of doing this without using indices. We just say if pxi is the same as, we keep track of what we want to delete soon to be deleted equals set. Alright, so, and that goes here. To be deleted is an empty set. If pxi is the same as pxi plus 1, we're saying now everything which matches pxi will be deleted. Eventually, but we're not going to do that yet. So we're not messing with the px list as we're doing this, because that messes all the for loops. So after this has gone through all of them. Oh, damn it. There's another issue. We're not remembering the indices. Do we need to? No, we don't need to know the indices. Oh, but we do need to know their corresponding... Okay then. All right. So we keep the px array this size. No sorting. None of that. But then that means. So this, we can't sort px. Px. Let's call this px temp equals px Stop putting it. Right. Px temp dot sort equals px copy of px. Okay. All right, forget all this. There's actually a much easier way of doing this. You don't need to make a px temp. You don't need to do that. Start again. To be deleted is an empty set. All right. Px set equals an empty set for p in px if p in px set to be deleted dot add p else px set dot add p. Okay, that's finding the duplicates. Any duplicates which are found are to be deleted. And now we do this. We say for I in range, let's say length of px minus 1 to ending on 0, going backwards. If this item is in the to be deleted set, then we delete it. So we go backwards so we're not interfering with the indices before. So the indices remain fixed. So so we delete px I, delete vx I, delete ax I. Okay. All right, that took way longer than it needed to be. All right, so we worked out what needs to be deleted. We do the deletion. Now we've got a new set of px's, vx's, and ax's, which is condensed. Now we execute one step. So how does this work? So for I in range, for I p in enumerate px. So A is fixed. A never changes. So the vx I equals tuple of k. So it's going to be I forget how Python zip works. This might be what I'm using here. Python zip method. I should know this by now. It's an important method, but okay, zip. We'll create tuples with, okay, good. All right, that's what we want. So the new velocity will be the old velocity. So we do zip the old velocity with the acceleration, and then we do sum we sum those two up. I don't know if there's a cleaner way of doing that. So that's updating the Vx, and the AX, the PX will be the P with the V. All right, time since last collision equals 0. So we reset time since last collision. So if time since class, so let's say while time since last collision is less than, I don't know, 100,000 for now. If that's not enough, we'll increase it. Alright, this is a whole mess of things, so I'm not sure about this. At the end, we want to just print the length of whatever's left. Unsupported operand between type of... No. What am I doing here? There should be a bracket there. One 58243. Well, that's the part one. Okay, let's decrease this to 10,000 then. Let's say there's no more, if there's no more collisions up to 10,000 steps, we're probably not going to have any more. It'd be very unlikely, but possible. Like they could intentionally set things up so that they'll collide. Or these integer numbers and they're not. Okay, 648 is what we've got. We started with 1,000, so we basically eliminated like 2/5 of them about. Okay, fine. Correct. I don't like my code there. It's pretty ugly. I think this is a problem you could solve pretty more cleanly with NumPy. This is a NumPy problem. It's a simulation in physics. You have vectors with lots of positions, velocities, accelerations. I mean, you'd get the same result, and I'm doing the same thing you would do, but I'm just kind of messing around with sets and indices and stuff. This is a scientific programming problem, really. But I mean, it worked. I wonder if, well, I don't think ChatGPT uses a NumPy. He might have one time. I'm not sure. I think he normally avoids using libraries like that, though. This might be hard for ChatGPT because it's not. You need to be smart. Well, the first part, I guess, is fine. It's the second part is he doesn't know what the input looks like, so he might not set a sensible break condition. But I went for 10,000. I think that's fine. I mean, the Manhattan distance didn't really seem to be relevant here. Why do we care about Manhattan distance? I guess that's how we calculate that, but it would be the same with Euclidean distance. It doesn't... Well, they had to choose one distance. Yeah, it is relevant for part 1. Yeah, okay, that's why we have Manhattan distance. It's not relevant for part 2. Oh, he's going down the simulation approach. Okay. So he's taking 1,000 steps. Is that enough? I mean, what kind of values do we have again? I don't think that's enough. 1,000 steps? Like, we're in the thousands here. I don't think that'll be enough to differentiate. But he did say we can adjust the amounts, okay. You know what? There's actually a problem in the problem description. I'd say this is this is a bad problem. Look at this. There's a space here. Why? There shouldn't be, because there isn't in the input. I get that that's supposed to represent the lack of minus sign to make it fixed width. But if you look at the input, that doesn't happen. So that's, if you weren't really looking hard at the input and you were trusting the problem description, as is reasonable to do, then... Okay, is that what has tripped up ChatGPT here? Possibly, I don't know. Okay, well, we'll give him a sample of the input then. Yeah, this was an example of actually a poor description. Because if you put a space there, naturally people are going to assume that's the standardized format for the input. Input is different from what the program expects. Yeah. Oh, he's talking about a different issue. What does he say? I don't really care. Let's just wait for the program. Get a input error. More than 3 sets of coordinates. No, it shouldn't. That shouldn't be the issue, should it? Okay, fine, whatever. There's no malformed input, but I don't know what the issue is. Okay. Particle none. It's not finding anything. Okay, that's a sensible approach. I like what he's done here. This is a program you don't have to fiddle with any hyperparameters or anything. It's not working. All right, last chance, ChatGPT. think ChatGPT is not smart enough to realize that it's actually just the particle with the lowest acceleration. That's all it is. You don't need to do all this simulation, but... Alright, this is the last attempt. I'm not going to give him any more chances. Nope. Alright, I'll just tell him he's wrong. Just so he knows. Alright, so that's a win for me then. Alright. That's been almost 1 hour 14 minutes. Can go for another problem. So we've got 1, 2, 3, 4, and then 25 is normally just part 1, no part 2. So if I do 21 today, that leaves a nice amount for a final stream, I guess. Fractal art, yay. Okay, doesn't look too scary. You find a program trying to generate some art. It uses a strange process that involves repeatedly enhancing the detail of an image through a set of rules. The image consists of a two-dimensional square grid of pixels that are either on or off. The program always begins with this pattern. Because the pattern is both 3 pixels wide and 3 pixels tall, it is said to have a size of 3. Then the program repeats the following process. If the size is evenly divisible by 2, break the pixels up into 2 by 2 squares and convert each 2 by 2 square into a 3 by 3 square by following the corresponding enhancement rule. Otherwise, the size is evenly divisible by 3. Break the pixels up into 3 by 3 squares. Convert each 3 by 3 square into a 4 by 4 square by following the corresponding enhancement rule. Fine. Because each square of pixels is replaced by a larger one, the image gains pixels and so its size increases. Missing rules. Oh, I don't think I have time for this problem if we're going to deal with rotations and stuff as well. I might leave this till next time. Yeah, this does look like a bit of a lengthy problem, actually. So I've got to interpret these rules, parse this, and oh, so you got this, and then you got... Yeah, this is a bit of work. I've got stuff to do, so I'll leave that till next time. It might be 2 more streams then to finish the lot. Unless I just put in a really long stream tomorrow. I kind of want to finish it soon. Alright, well that was up to 20. Let's have a look at how people did. What was the one I just did? Oh, the particle one. To be honest, I'm starting to realize that these times mean nothing. Like, no matter how hard a problem is, you'll get some people who solve it in minutes because they've done a lot of these competitions and they've seen these before and they recognize the problem. So actually, this is of no value to me, I suppose. The top 100 scores are not useful. I guess what would be more useful is like the median times or something like that. I don't know. So it looks like 21 is actually considered quite hard. And then 22 is actually considered easy. What was the first one I did? 19? The series of tubes. Yeah, that was actually sort of easy, but difficult to parse, but sort of easy. It looks like that corresponds with this. People actually did manage that one. pretty okay. So yeah, 21 looks like it might be hard. 22, easy. Looks like some sort of game of life thing. See, that looks less complicated than 21 because you don't have any of this rotating and splitting. Whatever. What's that? Sporifica. Okay. Cool. Alright, bye ChatGPT. So yep, that was output of code, problems. What did I start with? 19 to 21? No. 18 to 20 or 19 to 20. Just 2 problems? Really? I thought I did more. No, maybe it was just 2. All right then. I'm going to try and squeeze in a session tomorrow. If I can manage, maybe a long one. Let's just finish off the lot. That'll be nice. All right then, see you tomorrow, I guess.